Okay, so now we will start with area under the curve. Now, as you know that through definite integral, you know that you get a numerical value which basically is a number, obviously, and which tells you that which represents area under the curve. Okay, so the graphically, let's consider that this is your function, which is y is equals to f of x, and and on your x-axis you have two lines, which is x, which are x is equals to a and x is equals to b. So for finding the area under this curve with these two ranges, under these two ranges, this is the area which needs to be calculated. This is basically represented as, okay, so this is basically the area which is bounded by the curve, y is equals to f of x, the x-axis, and the lines x is equals to a and x is equals to b, which is basically given as this. This area is positive if it is above the x-axis, and negative if it's below the x-axis. But obviously you know that an area can never be negative, so you basically, while using your calculators, so basically you always consider a negative area as you don't consider an area as the negative, and you always use a modulus function to it. Okay, now this was basically the graphical representation of I can also show you, for this I can also show you this, that this is positive and this is negative. Now for our second point was area between a curve and the y-axis. So the graphical representation of this could be obviously, for example, this is your function. Now since it is between the curve and the y-axis, so let's assume that your two lines are x equals to c and y is equals to t. Let's call this as x is equals to gy, and now you have to find this area which is between the y-axis and this curve. So the area which is basically bounded by this curve, x is equals to gy, is the area bounded by the curve gy, the x-axis, and the lines y is equals to c and y is equals to d is basically given as c d g of y dy, or can also write this as x dy, correct? Okay, now our third topic was area between the two curves. For example, this is your x-axis, this is your y-axis, and this is your curve number 1, that is g of x, or let's call it as y1 for simple understanding. Let's call this as y1, and let's call this curve as y2. Okay, now you have to find this area between the two curves. Okay, now these are the intersection points of these. Now these are the points where these two graphs are intersecting. Okay, to find the area between these two curves, that is y1 and y2, we have to calculate you will have to calculate the x coordinates of the point of intersection, which will basically give you the upper and lower limit for integration. So you got it. In order to find the area between the two curves, you have to first find the point of intersection, which will be basically your limits. And one thing more which I would like to tell you, before applying integration, I'll tell you the formula for finding the area between the two curves, but one thing I'm just telling you beforehand, that before finding the area between these two curves, before you apply integration, you'll have to first simplify them. Okay, first you will, like, since these two curves are subtracting, and then you will, before applying integration to each one of it, you will first subtract them, you will get an expression, and then you will apply integration and you will enter your values. So the formula for finding the area between the two curves is basically integration of y2 minus y1 dx, and these are basically, these two values will be the upper value, and this is going to be the lower x coordinate and the upper x coordinate. And this could also be written as, this is basically the integration of the first one and integration of the second one. So instead of applying integration on each function and then applying limit first, the better idea is to first do the simplification and then apply integration on each one of it. Okay, now I will explain you that this claim that area is basically this claim that area is basically integration of a curve in the x-axis with the lines x is equals to and x is equals to b, and this particular formula, is it verified or no? So for that I will just show you, I will give you an example and I will tell you how is it verified. Let's consider that this is a triangle with base 2 and height 4. Now what is the area of triangle? Area of this triangle is equals to half base into height, which is basically half 2 into 4, which gives you 4 units square. Okay, now we have to basically, and which is basically now I have to, keeping this whole strategy, I will show you the verification of that claim, of that formula. Okay, now on a Cartesian grid we will move this on a Cartesian grid. Now this is your base 2, this is your height 4. Let's consider this as a line, as a translational line, and let's call it as x. So this is your function y is equals to 2x. Now this is your function. Now let's drop perpendiculars to get the vertices. This is going to be 2, this is going to be 4. Now the formula, the formula says a b f of x dx. So as per this, the function is what? 2x dx. The upper limit is 2 and the lower limit on the x-axis is 0. So let's apply and let's see if we get the same answer or no. It's going to be 2 over 2 x2 plus c. Okay, now since you don't put c because you know the exact position where this function is lying. Okay, so it's going to be a is equals to 0 to 2 square minus 0 square. So it's going to be a is equals to 4 units, which is basically verified through this formula as well. Now let's change a scenario. Let's see, by changing the scenario, does the area remains the same, or it remains the same, or it doesn't. Consider the same triangle and imagine that you have moved it 1 unit towards the on the x-axis. So it's like it was the x-axis was 2, now it is 3. Y-axis it's same, the function is now the function has changed. First it was y is equals to 2x. Now you have deviated it on the x-axis through 1 unit, so it's going to be. So now let's verify that is the area still the same. Is this area is still the same? As per the formula it says the limits are 1 and 3, x 2 minus 2x, 1 and 3, 3 square minus 2 into 3 minus 1 minus 2, 9, 6 minus 1 plus 2. So let's verify it. 9 minus 6 is 3, 3 minus 1 is 2, 2 plus 2 is 4. So it's verified as well. Now last one more scenario is, let's move our figure on the y-axis. This was 4, this was 2. Now it has moved 1 unit on the y-axis. First it was 4, so now let's call it 5. Now this is your x-axis, this is 2, this is 0. Okay, now if you just see, the function doesn't remain the same since it has moved on the y-axis. So the function obviously doesn't remain the same. Your function has changed to 2x plus 1 on the y-axis. Yes. So now let's verify. Area is equals to a b f of x dx. Area is equals to now your now what you need to find, now you obviously now you need to find the area below the curve, this whole area. Now this area has increased. If you just see that there's an emergence of a rectangle. So if this is 2 and this is 1, so the area of this rectangle is what? 2 units. So the whole area of this should be 6 units now. Now let's verify if we get the same scenario through this formula as well or no. So the lower limit is 0, upper limit on x-axis is 2. The function is now 2x plus 1. Let's integrate this. You will get 2 over 2 x2 plus x 0 to 2. 4 square plus 0. Sorry, 2 square. It is and 2 minus 0 plus 0. It's 4 plus 2, which is equals to 6 units square. So this is verified as well. Now I will show you a few examples, or before I start with the area under the area between the two curves, I will show you a few examples of, and we'll do few questions from our exercise books, so for a better understanding, and then we'll move to area between the two curves. Hope you are getting it.